discussion, we have discussed synthesis of nanomaterials or nanoparticles using salt gel method. It's a very simple step, 5-step method, right? So today we're going to see how to synthesize nanomaterials by precipitation method or chemical vapor condensation method. So to start with precipitation method. So in this method, in precipitation method, the inorganic salt, metal salt such as chloride, nitrite, acetate or oxychloride is dissolved in water. So, and the precipitation method can be used to prepare nanoparticles of metal oxides, metal sulfides, metals, metal chlorides, etc. So here, solid nanoparticles are obtained carefully from precipitation from their own solution. So how it is obtained? Let us see. The various steps involved in precipitation or synthesis of nanoparticles by precipitation method are: so metal containing exists in the form of metal cations which are existing in the form of metal hydride species, for example aluminum hydride or ferrous hydroxide. So these species are hydrolyzed by adding a base solution such as sodium hydroxide or ammonium hydroxide. So we're going to take metal cations such as which are already in the form of metal hydride species, for example hydrated aluminium or hydrated iron. We're going to hydrolyze it by adding a base solution such as sodium hydroxide or ammonium hydroxide. So these metal hydrates are added to precipitate as a precipitating agent. So then which causes on increasing the concentration of OH- ions, the hydrolyzed species condenses with each other to form respective metal hydroxides. So these metal hydroxides, so if you are adding sodium hydroxide, ammonium hydroxide to aluminium and add iron, you get aluminium hydroxide or iron hydroxide. So thus the concentration of solution increases and reaches a critical level, and that critical level is called as supersaturation. At this concentration, nucleus formation is initiated and the nucleus further grows into particles which gets precipitated. So the precipitate will be filtered to be washed with water, it is dried and it finally calcinated at high temperature. It is heated at very high temperature. So the dried powder is calcinated subsequently to obtain the final crystalline metal oxide in the nanoparticle form. For example, you can take gold nanoparticles which are obtained by precipitation method. When you take a aqueous gold solution, this is reduced with phosphorus in in mixed solution of carbon and disulfide and water. Okay, so we're going to take a rubbery colored aqueous solution of dispersed gold nanoparticles is obtained. So to prevent the precipitation of gold metal, nanoparticles of gold are passed to carbon sulfide solvent as soon as they are formed. So let us see what are the advantages of this. So the process is relatively economical compared to salt gel process. So we have wide range of single and multi-component oxide nanopowders are obtained. So the main disadvantage is inability to control the size of the particles and chances of aggregation of nanoparticles is more. So let us see how to synthesize nanoparticles by chemical vapor condensation method. So in this method, mixture of gas reactants are delivered into a reaction chamber. So inside the chamber, the chemical reaction occurs. A reaction among the gas molecules are induced by an input of energy such as resistant heating, laser and plasma. The product formed in the vapor state on condensation deposits nanoparticles and the byproduct reactants are exhausted. So what happens here mainly is the process involves the conversion of metal organic precursors such as halides, carbonyls, organometallic compounds and hydrides into vapors in a reduced pressure atmosphere, and subsequently they get dissociated by thermal energy to generate nuclei. Then once the nuclei is generated, it gets segregated to form nanoparticles. Let us take the example of one or two, that is silver nanowires, and how they are synthesized. So to take silver seeds which are first generated by heating silver nitrate at about 160 degrees Celsius in ethylene glycol, which serve both as reducing agent as well as a solvent. So this glycol will serve as a reducing agent and as a solvent. The surfactant used as PVP, that is polyvinyl pyridine. So a separate solution of silver nitrate and PVP in the ethylene glycol is then added dropwise dropwise to the seed solution, highly elongated silver structure is obtained. So we can also we can also prepare gallium arsenic semiconductor nanoparticles. So these are also synthesized by chemical vapor condensation method from organometallic precursors. So we're going to take a methyl gallium and arsenic hydride, which are used as precursors, and hydrogen is used as a carrier gas as well as a reducing agent, 2 in 1. So reaction occurs at very high temperature around at degrees Celsius and at atmospheric pressure. So what happens? Gallium arsenic nanoparticles are collected on a porous film. So around 350 degrees Celsius. So the product obtained is sized as a single crystal, that is gallium arsenic, with diameters ranging from 10 to 20 nanometer. The byproduct gas is easily removed out of reactor by carrier gas. So the main advantages are, this is a simple method, does not require ultra high vacuum, possible to deposit nanomaterials with almost any shape and any size. Byproducts and leftovers are easily removed. So allows formation of doped or multi-component nanoparticles by use of multiple precursors. So major disadvantages: precursors used are volatile and usually hazardous and extremely toxic. The byproducts are also toxic. So these are the advantages and disadvantages of chemical vapor condensation method. Thank you.